Good morning, everybody, and I'm very pleased to be with you this way. Thanks for the organizer to inviting me and to accept that I could not travel to be physically with you this morning, but this is a great conference, and I'm very pleased to be given an important slot and to walk you through the IEA views about the concentrating solar power role in the energy transition. We live in a world that is now getting invaded by cheap wind power and PV power, and we have to understand that. I mean, when I started working on CSP was the cheapest way of making solar electricity. It was twice as cheap or 3 times as cheap as photovoltaic. And indeed, this has changed. Today, it's in a way the opposite because PV. Wait. Okay, here you are. Both wind has reduced its cost significantly, but PV has basically crossed the entire space of cost, of electricity cost. So 10 years ago, it was the most expensive technology to produce electricity, and today it's clearly the least expensive, or one of the least expensive in many places on Earth. And this has been accelerated by the shift to auctions, from feed-in tariffs to auction, that has increased the competitive pressure on the developers and the manufacturers. In the meantime, CSP has made significant progress, especially in the last few years, exactly like offshore wind power, by the way, and again went down from over $300 per megawatt hour in some cases to 150, and now 75 or 77 in the best cases. And we expect this progress to continue as the technology develops. There is a learning by doing. There are lots of technical improvements. As in PV industry, we now see China entering in the area with big manufacturing capabilities, and we expect the price will still go down. But we don't expect that the CSP will be able to compete with PV on cost only. We expect it has a different value, and this is the key for its deployment. Look at what we have in the sustainable development scenario. This is first what we had in the past, the deployment of solar, PV, wind, and other renewable energy technologies in capacities compared to that of coal. I mean, coal should be negative if we are to address climate change. Gas and nuclear is very small. And here is what we see in our scenario, sustainable development scenario till 2040. We see coal decreasing in capacity and, of course, in energy. We see still gas increasing, but much more slowly than before. We see nuclear increasing a little faster than previously, and we see a huge amount of installation of renewables, especially solar, PV, and wind, but also bioenergy and geothermal and CSP and others. And of course, China, India, and the US are the leaders with respect to PV, while Europe is the frontrunner for onshore and offshore wind power. Now, what we know is that integrating large shares of PV is a challenge. And here you have the famous duck curve in California, where you see how from year to year the profile of net electricity production will change thanks to always increasing shares of PV. The net of PV production, what is the demand addressed to the rest of the system, becomes more and more complex, with lower and lower minimum runs and steeper and steeper ramps to satisfy, especially when the sun sets and the demand peaks because everybody goes home and lighten up all the lights, etc., etc., and air conditioners as well. So you see this curve, and this is what explains why CSP will have a much bigger value, especially when the space is invaded by more PV and wind. And here you have a study by our colleagues in the US showing that the capacity value of PV, which exists today, when you implement PV today in California, you can reduce the amount of gas peakers you need. This value will basically get reduced to very low level when you exceed 35% of energy from renewables, from variable renewables. But CSP, to the opposite, will keep its capacity value precisely because it's fully dispatchable, especially after sunset when the cost of electricity increases. And the beauty of CSP is that you can combine it with storage in very different ways. You can use it here just to shift the production. Instead of producing when the sun is here from 8 to 6 p.m., you can shift the production from, say, noon to midnight. That's easy. You increase the cost of electricity a little bit because of the cost of storage, but you increase the value in much larger proportion, and again, this gap in value will increase over time. You can use it to make almost a very peaking machine. In winter, that's probably what you would do in the new CSP plants in Morocco. You will accumulate the energy during the day and start producing only when the sun sets, and that you will do also in combination with PV. But you also have the possibility to go with a large storage and a small turbine and do round-the-clock production. And this is the lowest cost. Maybe not the highest value in the short term, but over time, when you need to fully decarbonize the electricity system, then this will be very precious. And that's what basically you may see in practice in Dubai with the new CSP plants, the 700 megawatts. Of course, the agreement is for producing electricity from 4 p.m. in the afternoon to 10 a.m. in the morning, covering the entire night. That will probably also cover the day, in fact, with a different price. This covers the highest price electricity, which is the first part of the night, and the lowest price electricity, which is the second part of the night. So over time, the optimal role and value will change. Till 2030, I would say you have a 1 day of production and energy mix of a mock system in a country that does not exist, which is a sunny country. You see the big role of PV, and then when the sun starts declining, you have CSP factoring in. But over time, you get almost fully decarbonized. You have more PV and you have more CSP, and CSP will basically work around the clock, except maybe during the day peak where PV might be enough, unless you prefer to run it continuously because there is a cost to start and go. So this is how we see it will change over time, 2030, 2050, or 60. Of course, CSP is not the only option for dispatchable power, and we have to be well aware of that. You can first think of a good combination of wind and PV in many places, like here in South Africa. It will help mimic the demand or match the demand if you have a good mix of wind and solar, and depending, of course, of the wind regime, you can approach the demand and match it even without CSP, at least at the beginning. You have demand-side response. And if the demand of electricity in many countries in the coming years, especially with global warming, will be driven by air conditioners, you can have a response which is based on efficient air conditioners and cold storage. I know a very cheap phase change material that's called water. You turn it into ice during the day when the PV is at its maximum, and during the night when you need still to cool the buildings because of the thermal inertia of the buildings, you use the thermal inertia of the icing, the ice making water, and you just need a fan, so you reduce the electricity consumption of the air conditioners to 20% of what it need be when you make the ice. And this will fit very well with PV. Basically, CSP would provide the same type of service. You have pumped hydro, and pumped hydro is growing everywhere. It's growing in countries you may not expect. It's growing in the Emirates. It's growing in Morocco, of course, in China and many other places. And here is an example of pumped hydro in project in the driest place on Earth, the best solar place on Earth, which is the Atacama Desert in North Chile, and they have conceived a project with pumped hydro of seawater. So even in the driest place on Earth, you can think of pumped hydro if you're not too far away from the ocean and you have a good cliff. So be aware that no, CSP is not the only way to address the complexity of the viability of the sunshine and the viability of the demand. And finally, you have batteries, and batteries are making tremendous improvements. Battery will never be able to do interseasonal storage, but CSP neither. In fact, what we foresee that if the current trend for cost decrease in batteries persists, we'll see the range, the economic range of battery going up from 2 hours storage today to 4 or 6 hours storage by 2030. And this also, even if, as you see here on this graph, has its cost diminishing, it may make, in a number of situations, the competition with battery more difficult. So we have to be well aware of all this. Finally, CSP is important for power, but it's also important for heat, and it's concentrating solar technologies. It's improving fast. Here you see the now famous, I think, glass point technology that produces heat. They have rethought all the system to protect it from strong winds and sand winds. And because of that, they have redesigned all the interior in a much lighter way and lots of improvements. And they produce steam for enhanced oil recovery operation in Oman with 1 gigawatt under construction, 2 other gigawatts to follow. California, 850 megawatts. All this megawatt thermal, but still it's important. And half of our energy needs in the world is for heat, bulk of it for industrial heat. This type of heat is very, very important, and in many countries, concentrated solar technologies can provide that heat. It may well be that in the future we also do high temperature concentrated solar heat, for example, for cement and other non-metallic minerals. You go up to 800 or 1000 degrees, and you could, with hot receiver, and you could then reduce very much the amount of fossil fuels used for cement making and for others. So it could provide partial solutions to the difficult task of decarbonizing the high temperature heat in industry. Of course, now the focus and interest of many countries is also looking at electrification and hydrogen. And here you see how we believe that renewable power can replace fossil fuel in many uses, in industry, in buildings, in transport, either directly, as you can see, or indirectly through water electrolysis, production of hydrogen, maybe its transformation in easier to handle chemical or fuel feedstock for industry. So here it's ammonia, which is already transported and stored in massive quantities as a feedstock for the fertilizer and explosive industries, but tomorrow could be a fuel in many cases in maritime transportation or in big power plants. That's what you go back to power plants maybe. We'll see what is the role of CSP in that. There can be several. One is to help firm part of the electricity, increase the capacity factor of the electrolyzers, and more importantly, perhaps, of the back-end plants that turn the hydrogen into ammonia or methanol or hydrocarbons or synthetic methane, whatever. Another role could be also to provide solar heat to the forthcoming technology of solid oxide electrolyzer cells, which will be much more efficient in transforming the electricity into hydrogen. So CSP also will find its uses in this world of electrification and use of hydrogen. Let me end with a few except from our scenarios. Here is our below 2-degree scenario a couple of years ago, but things have not changed dramatically. You see the role of fossil fuel renewables now coming in very importantly with biomass, hydro, etc., and wind, of course. Wind is blue here. And then on top of this, you will have the solar energy, and you see PV and CSP are both really important for this in this scenario. And we have a CSP capacity that would go beyond 1,000 gigawatts. Now, in the much shorter term, what do we see in our latest market report, Renewables 2018? We see basically doubling of the installation. There's something missing here in the slide. I don't know why. What we see in the total addition in China, Morocco, and Arab Emirates. In the base case, which is dark blue, but of course we have an accelerated case where these additions could also be more, at least at the end of the period. So basically, it's a return to growth for this industry. If you look farther in the scenario, not to 2060, but at least to 2040, this is a very recent scenario result, the World Energy Outlook 2018. In the new policy scenario, which is just basically the continuation of the pledges that have been made in Paris, we see up to 68 gigawatts of CSP by 2040. In the sustainable development scenario, you have 200 gigawatt more, so it's 267 gigawatt by 2040. Annual growth rate 12% in one case and almost 20% in the other case. So we need to be serious about climate change. So I really hope, and we at the IEA all really hope that we'll be able, with the help of government and industry, to follow the path of the sustainable development scenario. And this is a promising outlook for the CSP industry. We need the CSP industry all over the place. So thank you very much for your excellent work. Please keep on going, keep on the good work. We need you to help address the challenges of our times. Thank you very much for your attention. I'll be pleased to respond to any question if I can hear them.
Thank you. Thank you very much, Cédric. Yes, I open the floor to questions. Please identify yourselves when you ask the question.
Nino Consorzio Arca. The question is about economics, because I think that, again, this will be the point. How do you think that the scenario will be affected by the investments in improving the technologies? That will be, I think, the most important point, because you know that the PV rush has been pushed by the development of the Chinese industry, where the investment were so high. So who's going to bring the CSP in at this stage? Because in the United States, for example, there was a very relevant initiative, but which is the future on that? Which is your opinion on that?
Well, as I said, we expect the cost decrease will continue. I think in the even in the new policy scenario, there is an expectation that the cost of CSP will decrease by 30% by 2030. But that maybe not the cost starting from the very latest auction. That's certainly the cost of things that have already been commissioned throughout the world. So taking in account places where the costs were high, the costs were low, etc. We expect this cost decrease will come from 2 or 3 factors. One is the scaling up of the plants themselves. Another is mass production of the basic materials, whether heliostats or photographs or heat receiver elements or whatever. And a third, of course, will be learning by doing and research effects. I mean, there are plenty of ideas behind the scene. There are new concepts. There are new combination of concepts that are promising, and all this will play a role in the cost decrease. Having said so, we do not expect the price of CSP to ever come below that of PV, but we expect its value to be significantly higher than that of PV, especially in the future when increasing further the PV will not deliver much of usable electricity because it will come at times where the demand is already saturated, while adding CSP will allow to respond to our energy needs when PV electricity is not available, at least directly, without storage. That is in the evening, especially evening peaks, and later on throughout the whole night.
Thank you, Cédric. Anybody else wants to ask a question? Well, if not, I will ask you a question as well. Sure. I want to dwell on this idea a little bit further. How are we going to convince? I mean, so we know, we specialists of solar energy and of CSP, we know that there is an extra value for CSP compared with PV, and that's exactly what you're saying. And therefore, you're saying it will happen. The question is that now, when we look at what policymakers are thinking and what's happening in different countries, is that people are going for PV and just for PV. So how are we going to change the platform or the game in order to get to CSP sooner rather than later? I mean, do you have any feeling for this? Are you trying to, from a policy point of view, are you trying to find solutions to speed up the penetration of?
Okay. Well, indeed, it's a kind of permanent educational process, and we try to be part in our role of advising policymakers. First, in our member countries, who are the OECD member countries, but also through our associated countries. Now, you know that we have created an association that has been joined by India, China, Brazil, recently South Africa, Thailand, Morocco, Singapore, etc. So we're trying to work through these channels. We're also working together with IRENA, with the ISA, the International Solar Alliance, in order to help convey the same messages. Also in countries where we don't have the resource to go frequently. Let me just mention an initiative that we've just taken very recently. We are going to realize and publish a document which is a how-to guide, and that means, in fact, how to draft a solar roadmap in a country or in a region. And the idea behind that document is to give policymakers a number of basic information and policy advice on how to establish a roadmap for deployment and of solar energy technology. And the beauty of the thing is that it will include solar heating and cooling, photovoltaic, and concentrating solar power, because we think it's the same resource, different ways of harnessing it and using it. And it's important that policymakers understand that solar has at least 3 different forms that all should, at least in countries with good direct irradiation, should be able to contribute to our very diverse energy needs. So again, it's a continuous process. I mean, in democracies, policymakers change regularly, and we have to educate the new ones. But it's our job, and we keep on going, and we hope this document that will be launched in mid-2019 will be a useful tool for policymakers to get educated and to involve all stakeholders in their countries to develop solar roadmaps that give PV, CSP, and solar heat their optimal role in the deployment of the energy transition.
Yeah, well, thank you very much. I think that's a very important initiative that you keep on pushing with the available knowledge onto the politicians around the world. I think that's a very good idea. So we again thank you for your participation, Cédric, and we now close the session. Thank you very much.
I thank you. Thank you very much. Bye-bye.